Okay, now in an experiment of photoelectric effect, no current flows through the circuit when the voltage across the anode and cathode is 1.70 volt. Calculate the work function, the threshold wavelength of the metal, the cathode, and if it is illuminated by ultraviolet radiation of frequency 1.7. So you must read the whole questions, yeah, because you see, like this question, he give the radiation frequency in the end. So sometimes you miss out the information. Information is not at the front, but it's at the back of the questions. So you must read the whole question first. Okay, here what you can see is he said no current flows. No current flows if the voltage is applied is negative. Okay, why got a negative sign there? Why got a negative sign there? This negative sign is actually called the reverse voltage. Normally, why we apply reverse voltage? We apply reverse voltage because normally we do the stopping potential, isn't it? We're doing the stopping potential, stopping voltage. We try to stop, but reverse voltage, not necessarily stopping voltage. It's the stopping voltage is only when current is 0. Because it said no current flow. No current flow, that means no more electron reach the anode. The electron doesn't reach the anode. Maybe yeah. If you look back to my previous video about the stopping potential, you did see the electron after ejected being repelled by the, still remember about my videos. I have the cathode and anode. Okay, cathode and anode. This is the cathode. This is the anode. After reverse voltage, this one become positive plate, this one become negative plate, and the electron which is ejected out is being repelled by the anode. It's being repelled by the anode because we know that negative and negative charge they repel. So they repel. So the what we call the this is the positive and this is the negative. Okay, the voltage applied here when it's being repelled, the galvanometer here will show 0 reading, 0, because the electron cannot reach. No electron reach anode. No electron reach anode. So when no electron reach anode, that means no current flow in the circuit. Yeah, the electron cannot flow to the other terminal, so there will be no electron flow in the circuit. No electron flow. When no electron flow, the current becomes 0. So the voltage at this point, is called the stopping voltage. It is called the stopping voltage when it stops all the electron from reaching the anode. All electron being repelled away. So none of the electron can reach the anode, so current becomes 0. When current becomes 0, it is when this current becomes 0. It happens when stopping voltage. That's it. So when you see no current flow, current equal to 0, that means this is the stopping potential or stopping voltage. Okay. And the stopping voltage has a negative sign. Negative sign means reverse voltage. Reverse voltage, yeah. So stopping voltage is negative 1.70 V. That's the what means by negative. Negative means reverse voltage. Negative doesn't mean stopping voltage. Negative just means reverse voltage. But this value 1.7 has stopped completely the electron from reaching the anode and making the current equal to 0. So this value negative 1.7 is called the stopping voltage. Okay, when current equal to 0. So as long as you see when current equal to 0, it is happen when stopping potential or stopping voltage. Actually got two conditions. Current equal to 0 can be maybe is because of stopping voltage, or the other is maybe the photon doesn't have enough energy. Actually has the two conditions to have current equal to 0. It's either maybe the photon doesn't carry enough energy, doesn't have the frequency is less than the threshold frequency. The energy of the photon, maybe the energy of photon less than the work function. No electron can ejected, no electron can eject, no electron can eject. Also current will equal to 0. Also current equal to 0. The other condition is this one lah, stopping voltage. Electron can be ejected. Electron still can be ejected, yeah, by the photon, by the incoming photon. The electron can still be ejected, but it's totally being repelled by a stopping voltage. So there are two conditions for current equal to 0. The first one may be the photon energy less than the work function, not enough energy to overcome the work function. So not enough energy to overcome the binding energy, so no electron ejected. Also current will become 0. Or the other condition is it happens when electron is ejected, but all the electron is totally repelled by the anode because of the reverse voltage stopping potential. So that condition also current will become 0. Yeah. So you need to identify which one. So for this one is about negative reverse voltage. So definitely this is about this current equal to 0 means stopping voltage. Okay, this one. Okay, now we want to find the work function. We are provided with the stopping potential. What is the use of this? We want to find the work function. We use the photoelectric effect equation, Einstein photoelectric effect equation. So we have the stopping potential Vs. We can find the Kmax. Kmax equal to EVS. Once we got the Kmax already, we can substitute into here Kmax. And to find the work function, we need another energy of photon. Energy of photon, we have the frequency here. Do you see that? This is the frequency of the incident ray. So this one will help us to find the energy of the incident photon, energy of the incident, energy of, not E equal to F lambda, it's E equal to HF, E equal to HF. So this frequency can help us to find the energy of the incident photon. So we got the E here, we also got the Kmax here. That's why it's very important for you to read the whole question first until the end. Then you can find all the information required. Like this one, the information required is at the end, at the back of the questions. Yeah, we need this frequency to find the E. You see? So you need to read the whole question first. Yeah. Then only can solve the question. So before you trying the question, make sure you read the whole question. Now, from the front to the back. Okay, now let's find the Kmax. Let's find the Kmax. We have the to find the Kmax is EVS, electron times the stopping voltage. So electron charge is 1.6 exponent negative 19. Stopping voltage. Remember during calculation, just ignore. Yeah. Ignore the negative during calculation. You only put the negative sign when you need to give the stopping voltage as your final answer. Yeah, as your final answer. But during calculation, just ignore the negative sign. So we don't substitute negative 1.7. We just substitute 1.7 enough. Yeah. We just substitute 1.7 enough. Just ignore the negative sign. Okay. We just want the value. Just want the value. Okay. So after multiply, what do we get? Yeah. Just punch your calculator, and the answer turned out to be 2.72 exponent negative 19 joule. You get this unit in SI. Yeah. Joule, SI unit. You won't get in electron volt. Yeah, you won't get in electron volt. You only get the SI unit, joule. To convert to electron volt, you need to convert yourself lah. Yeah, divide by electron charge. Now, I already got the Kmax. Now I need to find the I already got the Kmax. Now I need to find the E, energy of the incident photon. So I have the frequency here. I have the frequency, so just use E equal to HF. Equal to HF, so H is 6.63 exponent negative 34. Multiply by the frequency is 1.7 exponent. This is the frequency, you see, 1.7 exponent 15. Okay, 1.7 exponent 15. Okay, that's the frequency. So what is our energy? Our energy is 6.63 exponent negative 34, and then multiply by 1.7 exponent 15. The answer is 1.1271 exponent negative 18 joule. Also the unit in joule. Make sure all in unit joule. All the answer you still get joule. To get electron volt, you have to convert by your own. Always the formula will give you joule first. Okay, you always give you the SI unit first. Okay, so you get this energy in joule. So now to calculate the work function, we will also get in joule. To get the work function, we also get the answer in joule. Okay, you just give the answer in joule. Unless the question specifically asks you to find the work function in electron volt. In electron volt. This one doesn't specify at all, so you just give in joule. Okay, normally we just give the answer in SI unit. We only give the electron volt non-SI unit when it is being asked by the question. Okay, so this one, the question doesn't ask for any unit. You just give the SI unit joule. Okay, so alright, so just write down all the information there, and then we solve it. This is 1, 2, this one exponent negative 18 joule. Okay, and then Kmax is 2.72 exponent negative 19, also in joule. Plus work function. So my work function is equal to what's my answer for my work function? Let's calculate. So okay, my work function is okay, minus 2. This is negative 18. This is negative 18. This is negative 19. Okay, exponent negative 19. Okay, so I get the answer in 8.551 exponent negative 19 joule. Is that correct? Is that correct? Yes, the final answer is correct. Work function 8.55 negative 19. You see, 8.55 exponent negative 19 joule. That's correct, my answer. Okay, now let's move on. What's the threshold wavelength of the metal of the cathode? Okay, remember this is the cathode. Normally electron is ejected from the cathode. Electron is ejected from the cathode, not anode. Electron electron ejected from cathode. Okay, anode is the collector. Anode is the collector of electron. Is the collector. Cathode is the one who eject the electron and receive. Cathode is the one who receive the incident ray. He received the incident ray. Cathode. Okay, cathode is the one that receive the incident ray, and also is where the electron ejected. Okay, anode is just the collector. So now let's go find the threshold wavelength. Threshold wavelength, we just make use of the work function. Because we know that work function is equal to hc over lambda naught. So work function can help us to find the threshold wavelength, also the threshold frequency. We can find the threshold wavelength and threshold frequency from the work function. Okay, and make sure these all in SI unit. Make sure all in SI unit joule. The work function must be in joule first. If you got the work function in electron volt, you must convert to joule first before you can substitute into here. Because why? Why the work function here must be joule? Because our Planck constant H is joule second. You understand? our Planck constant is unit joule second. Joule second. Joule second. So that's why the work function here also in joule, energy unit joule. Okay, so now this is just substitute. Okay, I got the work function in joule, so it's safe for me to substitute. If electron volt, I need to convert first. Okay, this one can straight away substitute. So Planck constant is 6.63 exponent negative 34. And then my speed of light, okay, let's find out the speed of light. The speed of light, 3.0 exponent 8, speed of light over the threshold wavelength. So in the end, the threshold wavelength, I will get the answer in, let me see, our threshold wavelength, okay, it is 2.33 exponent negative 7. If you want to convert to meter, then you have to, this one become 233, this one become negative 9, negative 9 is nano, negative 9 is nanometer. So you can either give in SI unit meter or you can give in nanometer, both accepted. Okay, normally we just give in SI unit lah, meter. Yeah, we don't bother about the nanometer. We just give the answer in meter. That's enough already. Okay, so that's the answer for my threshold wavelength. Okay, so okay, see you in the next video.